Welcome to my presentation. In this presentation, let us try to find the angle between two vectors. If the vectors are given to us in this manner, in this example, let us say vector u is 1, 1, 1. These are the components of vector u, and the components of vector v. Let me write this again. Components of vector v are 2, 1, -1. And if these are two vectors in R3 spaces, we want to find the angle theta. We want to find the angle theta between these two vectors. Okay, the way to do that is as follows. Step number 1. We want to recall that the angle between the two vectors is given by cosine theta is equal to vector u dot vector v divided by the magnitude of vector u times the magnitude of vector v. So that's the way we can write it up. In step 2, we will try to substitute the values what we have. Cosine theta is going to be equal to vector u is 1, 1, 1, and then vector v is 2, 1, 1, and then the magnitude of vector u is going to be the square root of 1 squared plus 1 squared plus 1 squared, and then the magnitude of vector v is going to be 2 squared plus 1 squared plus -1 raised to the power of 2 with a square root on top of that. So now it is just a matter of simplifying the math in here, and the way to do that is as follows. This is going to be equal to the dot product of between these two vectors is going to be 1 times 2 plus 1 times 1 plus 1 times -1, and in the denominator we have 1 squared is 1 plus 1 squared is 1 plus 1 squared is 1. So therefore that is that part. And then in the second part we have 2 squared is 4, 1 squared is 1, and then -1 raised to the power of 2 is 1. So when we simplify this some more, 1 times 2 is 2, 1 times 1 is 1, 1 times -1 is -1, and then divided by square root of 3 times 4 plus 1 is 5, 5 plus 1 is 6, square root of 6. So that is what we have there, and therefore when we simplify this simplifies to 2 divided by 6 times 3 is 18, or I can also write this one as square root of 3 times square root of 3 times square root of 2, isn't it? 3 times 2 is 6, so therefore when we multiply square root of 3 times square root of 3, it comes out as a radical term, comes out of the radical term, and then we can write this one as 2 divided by 3 square root of 2, like that. Therefore when we can further simplify this and then write this one out as square root of 2 divided by 3, because 2 means square root of 2 times square root of 2. We have a square root of 2 in the denominator, we can cancel that out, therefore it comes down to square root of 2 divided by 3. And now this is what we have. Cosine theta is equal to square root of 2 divided by 3, and therefore we want to find the value of theta, and therefore the way to do that is as follows. Theta is equal to cosine inverse of square root of 2 divided by 3, and when we simplify that, this simplifies to 0.6155 radians. We can express the measure of the angle in terms of radians, or we can also express the measure of that angle in terms of degrees. In terms of degrees, it is going to be 35.265 0.44 degrees. Okay, so these are the two ways of writing, expressing the answer. Again, degrees, the difference between degrees and radians is if you were to take a circle, and then if we were to represent degrees in here, it is going to be 0 degrees, 0 degrees, 90 degrees, 180 degrees, 270 degrees, and then back to 0. This would be 360 degrees, and then we're going to measure in the counterclockwise direction like that. On the other hand, the radian measure is as follows. We're going to start from the positive x-axis, which is 0 radians. Then the positive y-axis will be pi over 2 radians. Then this negative x-axis will be pi radians, and then this will be 3 pi over 2 radians, and then back to 0 will be 2 pi radians. So this is the difference between degrees and radians, and as I mentioned, we can represent the measure of an angle in terms of radians or in terms of degrees, as shown here. In my next presentation, we shall see some more examples, and then try and evaluate the angle between those vectors.